We just learned about the pull down and the pull up resistors, and so we had this issue where the value was kind of floating after the button was pressed and wasn't going to where we'd expect it to go when the value wasn't pressed, or when the button wasn't pressed. So like on this one it would be at 5 volts when it should be at 0. This one might be at 0 volts when it's supposed to be at 5 volts. And it would make the buttons not behave appropriately, and so the way that we solve this problem is using these pull down or pull up resistors. There's actually an easier way to do this, and so I'm going to go ahead and show you that now. So we're going to get rid of these resistors. I'll just go ahead and delete them. And so what it turns out is that built into all of these GPIO pins is an internal resistor for pulling up. So we don't have a pull down resistor, but we have a pull up, and we get this by, instead of doing input, we say input pull up. Okay, and we'll see what happens here. Okay, and so now this allows us to pull to the 5 volts when the button's not being pressed, and then when it is being pressed it can go down to the 0. And so what that means is, though, it's going to kind of flip the logic on the buttons, right? So we when we start this simulation, we'll see that it doesn't work. Oh, didn't like that. Let's see. Expected initializer before. Oh, I don't have the equal sign there. I don't think. There you go. And so we'll see here when we run this simulation that one of them doesn't work the way we expect it to. Okay, so if I press this button here, the one that's connected to 5 volts, it's always connected to 5 volts now because we have that pull up resistor. So when this is not pressed, it's pulled up to 5. And so this one, on the other hand, when I press it, we can see it goes down to 0. When it's not pressed, it goes up to 1. And so this is what we're going to do going forward is we'll have our buttons wired in reverse. We'll have them connected to ground and to the digital pin with the input pull up, and that's going to allow us to avoid using that resistor as a pull up or a pull down. So that saves us just some extra headache on the wiring side of things, makes things a little bit easier to work with, and now we have a button that behaves it the way we expect it to. The trade-off, of course, here is that we can't, the logic is kind of flipped, right? And so when for it to be pressed, it's going to be when it reads 0 instead of 1, and when it's not pressed, it's going to be reading 1 instead of 0. Let's code a quick example with this. Let's say we've got this one here, so we want to move this back down to ground now, so that it's reading 0 when pressed, and it's being pulled up. Otherwise, we'll add an LED with the resistor, and then we'll connect this to one of our pins. We'll go to pin 3, okay, and change this to be 330 ohms. Okay, so now let's do some code. So let's say we're checking our button, so it's pin 8 again, and we'll actually go ahead and make a variable here. So int button pin equal to 8, and so we'll put that variable in here, so we can change that pretty easily. And this is really the best practice. I like to, when I'm demonstrating here, use it without the variables, because in my experience, when we're learning how to do this stuff, we can confuse the variables with the actual object itself. Okay, so we're reading the pin connected to the button, and we're saving that as the button status. And what we can do now is we can say if button status is equal to low, because remember that's what's happening when it's pressed. We can do like a digital write here. Oops. And we'll say digital, and then we can set pin 3. So I guess we need another variable here, right? So int LED pin equal to 3. We'll write 3 to high. Okay, and then we can do an else statement and say digital write, and then we'll set 3 to low. Okay. And also it might be worthwhile, so let's make sure we set our pin mode. So we'll say pin mode, LED pin, comma, output. And for some reason I didn't even use the variable we created here, so I'm going to copy this and I'll paste it right here and right there. Okay, so we run this code and now it's going to do the oh, got to put a semicolon, right? Now we'll be able to control with the button here. So we press the button and it should come on. Yep, we press the button, it goes off. And I wonder why it's fading off so slowly. I wonder if this is the fact of this. Oh, okay, let's add a delay here. The simulation is just going really fast. Stop the simulation. We'll give ourselves a very short delay just so the simulation can run a little slower. There we go. And now we press it and it comes off, etc. It's still going kind of slow to fade out, but okay. Now there's actually even a better way to do this, or at least an easier way. Maybe not a better way, right? Sometimes easier isn't better, or sometimes less code isn't better. Okay, so we did this in 1, 2, 3, 4, 5, 6, 7 lines of code. We can change this to 2 lines here, and we can get rid of all of these things. So let's comment out these lines. And so really all we have to do is we read the button and we set the LED status based on the status of the button. And so a really efficient way to do this would just to be to digital write the LED based on the status of the button. So we can say digital read inside of our digital write function. And then we can, and again, there's nothing wrong with the way we did it before, but I'm just showing you there's another way we can do this. And if we were like trying to really like scale down our code, this would be something we could do. Okay, now this is actually going to do the opposite of what we want, and we'll talk about why that is in just a second here. So we run this. Okay, what did I do this time? Too few arguments. Oh, there you go. Oops. Okay, so I have to tell it the pin mode, right? So we're going to say LED pin, comma, and then we'll write it to the level of the button. So I'll press start simulation. And now we're going to see the LED's on, and then when we press the button, it goes off, right? And so if we want to flip that, what we do is we have to flip the logic of this button. And so remember, we have the not logical operator, which is the exclamation point. So if I stick the exclamation point in front of this digital read, then it's going to flip that logic there, so that it's going to take, essentially what's happening is this single line of code is doing all the work for us, right? We're going to start here and we're going to read what the button says, and this is going to come back and this is going to turn into either a 0 or a 1 depending on this button status. So when the button is pressed, it reads a 0. When it's not pressed, it reads a 1. Now we want the LED to light up when the button's pressed, and so we have to send to the digital write function the number 1 or the word high to tell that LED to light up. Okay, but when we press the button, it's getting the 0 volts, and so it's going to read as low. So we flip this signal with the not operator, and so not 0 is 1, not 1 is 0, and so then when this comes back pressed as 0, then this gives us a 1, and then we write LED pin to level 1, and so it's going to turn it to high, and then this is low, or this is set to high. When the button's not pressed, it's going to write that LED to low. Okay, so that was a lot, and this is a kind of a, I can understand if you're a little bit confused by this, but just wanted to show it just so you can see there's actually an easier way here. Not easier, just I guess more efficient way to do this. Okay, and so again, I guess the takeaway here is this is a really great way to do it. Don't feel like you have to do it like this, especially if you're having trouble understanding this. Those kind of things will become easier over time, but this is a great way to do it. Just remember that when we're using that internal pull-up resistor, we want to connect that button to ground instead of 5-volt, and we're looking to see when the button is low for when it's pressed. Okay, So that is we'll stop here, and that's everything with internal pull-ups. Hopefully you're kind of feeling you're at a point now where you can write code to control things with a button. Definitely ask some questions if you're confused or stuck.